Hello, everyone. I hope you're enjoying BioC Asia 2022. I would like to thank the conference organizers for inviting the Bioconductor core team to speak today. I'm Lori Shepard-Kern, and last year I presented on what is Bioconductor and how the core team plays an essential role, which is still a great overview of key concepts of Bioconductor and the core team responsibilities. It is still available on the Bioconductor YouTube channel, and I encourage everyone to view the recording from last year. This year, the core team would like to present on core team updates from the last year, upcoming changes, and current projects of interest. While the core team meets weekly to stay up to date on everyone's progress and projects, I thought it best to hear from a few of them directly and have asked a few members to make short lightning talks to highlight their work and interests. First up is Vince, who supervises the core team activities.
Hi folks, Vince Carey here. Happy to tell you a little bit about my work with Bioconductor Core. So I'll just share screen for a minute, try and pick that out and get a little presentation going here. Yeah, I'm at Harvard. I've been in the project for a long time, have some code pretty deep in the project. PI with Rafi Rosari of the Core Funding Grant from NHGRI. I've had a number of other projects, chair of the Bioconductor Tech Advisory Board and report to the Scientific Advisory Board and teach in various places. I've been involved with thinking about how to get data out of the cloud in ways that don't involve thinking about more than just R and its matrix and array and data frame idioms. Very concerned about instrumentation and efficiency. We'll show a little bit more about that towards the end. Been doing work on interfacing to machine learning in various schemes and ontology networks. I have old packages helping us to work with those. Human genetics and clinical, the GWAS catalog, BioC Fire is a new package. And my general hope is to, work on getting the ecosystem as a whole smoothly functioning so that the core devs have a sane work experience and a favorable career path. And one of the things that I like to think about is shown in this display that's collaborative work with Yubo Cheng and Martin Morgan, where we look at an hour-long workflow doing some stuff from the OSCA book, and we chart just how much of the computer that we've allocated gets used throughout this workflow. And what you find is that there's many intervals where the resources in use are much less than the resources that have been committed to do the job. And trying to use this type of information to reduce costs and help us figure out where the bottlenecks are, the kind of thing I like to work on. Thanks a lot.
Next, we have Marcel. He works on a number of projects, but is going to highlight his work on two very important packages for Bioconductor: BioC Manager for installing Bioconductor packages, and BioCheck, a package that provides a check for a package in development to make sure it's adhering to Bioconductor-specific package requirements and guidelines.
My name is Marcel Ramos, and I work for the Bioconductor core team at Roswell Park and the Waldron Lab at the CUNY School of Public Health. You may recognize me by my avatar on GitHub, seen here. I'm also on Twitter and Slack if you'd like to reach out. Feel free. I work on a couple of main projects. One is BioC Manager, which is a package that allows access to the Bioconductor ecosystem. So it allows you to install all of the packages based on the current version of R and Bioconductor that you wish to use. It also validates and updates all of the Bioconductor installations. It's a package hosted on CRAN, and it now allows you to install binary packages if you're on the containerized version of Bioconductor. We've also recently worked with our offline users who have enterprise systems that are offline and want to use Bioconductor, so we ensure that they have access to all of the infrastructure. Some of the future directions for BioC Manager is to enhance reproducibility. We're currently working on these so-called time machines, which are these repositories that of or snapshots of CRAN packages in the past that are served by either the RStudio package manager or the Microsoft R Archive network. And we're designing these to work alongside the Bioconductor version, so you can install older packages of CRAN alongside Bioconductor. The other project that I work on is BiocCheck, which is a package to maintain the Bioconductor ecosystem's integrity. And this happens through package submissions. So we recommend all of our reviewers to use BiocCheck on the package, as well as the maintainers should run BiocCheck, certainly. And what BiocCheck does, it checks against the Bioconductor standards and ensures that all of the packages adhere to those standards. Essentially, the package is a translation of the contributions.bioconductor.org website into some programmable and practical checks of the package code. So this allows our reviewers to focus on the broader implications, perhaps the scientific merits of the submissions, rather than the code base itself. And we would like to run BiocCheck on the current ecosystem so that we have a mechanism to collect all of the BiocCheck results from the current packages and be able to help our developers adhere more closely to the Bioconductor standards. And then the BiocCheck maintenance is an ongoing process because the recommendations can change or there can be additional recommendations. So these are the two main projects that I work on, but there are many more. And thank you all for listening, and feel free to reach out.
And now we have Alex, who will talk about managing Bioconductor core infrastructure resources and software stacks, as well as some of the collaborative projects.
Hello, my name's Alex. I'm a software engineer at the Channing at Harvard Medical School, and I joined the Bioconductor core team about a year ago. At Bioconductor, I manage a few of our core infrastructure resources. Earlier this year, we got an allocation on the National Science Foundation's JetStream 2 cloud, which is basically an academic version of clouds like AWS, Azure, or GCP, and gives us access to compute resources including both CPUs and GPUs. Since getting this allocation, we've been gradually working on transferring some of our stacks to the new cloud where possible, and it hosts a few new services that we're looking to offer, such as the Bioconductor Workshop instance or the Yes4Cure instance that I will mention later. In terms of storage resources, we also got an allocation on the Open Storage Network, where we currently have a 40 terabyte egress-free storage on US-based buckets. In addition to this allocation, we've partnered with the Galaxy project, taking part in the AWS Open Data Science project, where we have a Sydney-based bucket with Bioconductor data, which also does not cost us any egress. This is particularly relevant in the context of creating a more distributed, egress-free network of buckets and setting up an environment where users would get the resources they request from the closest location to their machine. Beyond maintaining resources, there are also some software stacks on which I'm a primary maintainer, namely the containerization and Kubernetes stacks. This includes Bioconductor Docker, which are the images for Bioconductor based on Docker's containers, and which are often an easy way to get started with Docker on a new machine. I've also been bringing Kubernetes more into the Bioconductor world slowly, so there's this Bioconductor Helm chart which provides out-of-the-box deployment on a Kubernetes cluster and includes tutorials for 3 major cloud providers. And finally, the binary production stack BiocCubeinstall, which dispatches weekly builds on Kubernetes on the Google Cloud to build binaries for the container image. In terms of some of the collaborations with other projects, I came to Bioconductor from the Galaxy project, and I've been trying to bridge some areas of overlap between the two, so I've been playing around with the idea of Bioconductor interactive tools in Galaxy. We also have a collaboration with the Yes4Cure program at Dana-Farber and Harvard Cancer Center. We're using a custom Galaxy deployment. Running on the JetStream 2 cloud. Vince taught a class of about a dozen students about the basics of cancer data science with Jupyter notebooks. Following this course, there was also some work put into generalizing the stack so that it can be redeployed with any material in the future. Finally, I also maintained the Bioconductor Anvil container images, which are the primary way in which Anvil users can use Bioconductor in Terra, and have been serving as the project manager for Bioconductor in Anvil for the past few months. Beyond recurring tasks, I wanted to highlight some of the main projects I've been working on pushing forward. In terms of properly utilizing all the new object store locations I've been working on a geo-based redirect for our buckets, which will hopefully go into production relatively soon. I've been playing around with GitHub Actions in terms of building the binaries for the containers instead of relying on and paying for Google Cloud, but also GitHub Actions for testing of packages, which I'm hoping will make it easier to test packages for authors, package reviewers, and the core team in terms of building later. And I've been working on getting Bioconductor interactive tools for Galaxy out there and standardizing a concept of deployable Bioconductor resources and a stack to deploy them. So we could take any material in the form of vignettes, Quarto documents, Jupyter notebooks, and have out of them some deployable artifacts that can be run anywhere via Docker, on Kubernetes via Helm, in Galaxy via interactive tools, or in Terra/Anvil via custom environments. Finally, as a long-term pet project, I've been looking into creating a Kubernetes client R package to interact with the Kubernetes API within R.
Next up, we have Jennifer, who has been helping maintain and enhance the Bioconductor build system and taking a leading role in organizing Bioconductor's participation in Outreachy.
Hi, I'm Jen. I'm a developer in the Waldron Lab at the CUNY Graduate School of Public Health and Health Policy and a member of the Bioconductor core team. My primary duties for Bioconductor revolve around maintaining the Bioconductor build system. This is the network of about 7 machines running different operating systems spread across 3 locations, running code to build Bioconductor, develop and release packages, as well as to generate artifacts such as tarballs and the build reports. More recently, for the 3.16 release, I added Mac ARM64 binaries, and I'll do the same for the 3.17 release soon. Another project that I've been working on is getting Bioconductor involved with Outreachy, which is an organization that provides open source, open science internships for those subject to systemic bias and underrepresentation in technology. Bioconductor was accepted for the December 22, March 23 internship round. We received funding for 2 interns. Participating projects for this round are Refactor the BS Genome Forge tools, which will be mentored by Hervé Pages, and Convert Swift vignettes to R Markdown, which is also known as Swift RMD, which I'll mentor. If you have a Bioconductor project that's open source and you'd like to mentor someone, the next call for projects will likely be around January of next year, and the projects will be finalized around March. So please look for the announcement in the Bioconductor community Slack or on the Twitter. So Swift RMD is one of the projects that's participating in Outreachy this round. It's a community project that aims to convert all the older Swift vignettes and Bioconductor packages into R Markdown for easier maintenance. We have about 900 Swift vignettes, so that we need a lot of help to convert these to R Markdown, which will make them easier to maintain. It also allows us to convert them to HTML, and it works with BioC style. If you're interested in getting involved, please check our GitHub at Swift RMD.
Next up, we have longstanding core team member Hervé. Hervé has been a member of the Bioconductor core team since 2005 and is currently located at the Fred Hutch Cancer Institute in Seattle. Unfortunately, Hervé was unable to video, but we have a few slides he's provided. So Hervé maintains many significant infrastructure packages for Bioconductor. These packages listed here are only a few, but if you've worked with Bioconductor, you likely have utilized one of these important Bioconductor packages. Currently, Hervé is working on a new package for efficient sparse array representation in R called Sparse Array, which will be submitted to Bioconductor and available soon. Many of the infrastructure packages Hervé maintains involve implementation and integration of C code within R. This allows for better efficiency in certain situations. So some example functions that are programmed in C are listed here. Bioconductor is also unique in that we provide annotation packages, and Hervé is involved with two important suites of annotation packages, BS Genome and the SNP LOCS packages. Hervé is really essential to the Bioconductor project, and there are many other activities Hervé has a role in, including documentation for all areas of the project, offering support of the key infrastructure packages to users on the various support outlets, running the daily Bioconductor build system, amongst many other activities. Most recently, Hervé is also participating as a mentor in the first round of outreachy projects that Bioconductor is participating in that you heard a little bit about from Jennifer earlier. So Hervé really is essential in keeping Bioconductor running smoothly and efficiently. Now that you've heard from some of the core team directly, I'll highlight some of my own work, updates, and highlights to the project from the past year. So again, my name is Lori Shepard-Kern, and I currently work at Roswell Park Comprehensive Cancer Center in Buffalo, New York for the Bioconductor project as a programmer and project manager. I've been working for Bioconductor for several years now and very much enjoy the project and the people I've met throughout the years. My involvement includes currently acting as the Community Advisory Board Secretary, sitting on the Technical Advisory Board, participating and leading several community working groups and committees, which I'll talk a little bit about shortly. I help maintain Bioconductor core packages and Bioconductor system infrastructure, but most notably I handle Bioconductor hubs, the Experiment Hub and Annotation Hub, and BioC File Cache. I also am the administrator and coordinator for new package submissions and any system or code relating to the ingestion of new packages. I also have taken over administration of Bioconductor Git credentials, maintainer access to existing packages, and package hooks. I manage Bioconductor resources on Amazon Web Services and Microsoft Azure Data Lakes. I help update and run Bioconductor websites, which include the main bioconductor.org site, the support site with lots of assistance from BioStars, most notably Nate, and the Bioconductor package guidelines and standards at contributions.bioconductor.org. I help organize and individuals requesting public and private Bioconductor mirrors. And these are just a few of the many tasks that I am responsible for. I talked last year about the Bioconductor ecosystem and highlighted many areas of the project. Again, please take the time to watch the video from last year as it's a great overview. I just want to touch upon a few changes from last year. So last year, I talked briefly about hosting large data as Git does not allow large files and we do not currently support Git LFS. And as part of the Bioconductor standards, we require data to either be pulled directly from web resources and cached, like data from Ensemble or NCBI resources, or hosted on a secure public server like Zenodo or Amazon S3 buckets, to name a few, and not to be hosted on private locations like GitHub or Dropbox. If a developer does not have access to a secure server, Bioconductor provides a default location. That location is changed. This location is switched from Amazon S3 buckets to Microsoft Azure Data Lakes. So all data Bioconductor hosted for the Experiment Hub and Annotation Hub has also been moved over to that new default location on Microsoft Azure. Users should not have experienced an interruption, and the change should have gone relatively unnoticed. The change mostly affects contributors to the Experiment Hub and Annotation Hub and maintainers wishing to use Bioconductor to host data, as the instructions for uploading the data has changed. I didn't talk about this directly last year, but Bioconductor retains old versions of packages for earlier Bioconductor releases, so a user could potentially use a legacy version of Bioconductor like 2.18, 3.6, 3.12, instead of using the current 3.16 release. It's always recommended to use the latest R and Bioconductor versions, but we understand that for data reproducibility and because not all users have access to update the versions of R and Bioconductor on, say, an institutional system, that these versions need to exist. The old location of what we call the archive versions of Bioconductor were stored as much as possible on the Amazon CloudFront, and then moved older releases to an Amazon S3 bucket. This process has now changed. We now only host current release and develop versions of Bioconductor on the CloudFront, and when there is a new release, we move legacy versions to an Exceed open storage network. This change had great improvements for the administration side as far as cost of storage of data, as well as egress charges. There has been minimal disturbance to users accessing these older releases, but please reach out if you have any difficulty. So now I'd like to switch topics a little and talk more about initiatives started by the Community Advisory Board that both the Community Advisory Board and Technical Advisory Board would like to highlight for community involvement. It was announced briefly at BioC 2022, but it's the idea of Bioconductor working groups and committees. We often can recognize gaps and shortcomings of the project, but don't have enough people or time to actively work on them. With a large Bioconductor community eager to get involved, we thought that if we could keep track of ideas and projects that are needed, that the community could work together in making improvements. We have started a rough webpage at workinggroup.bioconductor.org to list the guidelines for suggesting a working group or committee. The currently active working groups that have been identified as needed but need someone to lead and form a group to actively work on the issue, and inactive working groups that were started and finished their goals and have since disbanded. Anyone can start a working group. To be officially sanctioned working group, we would ask that a pull request is submitted to the workinggroup.bioconductor.org GitHub with details on why the group is important, what gap or insufficiency has been identified in the project, and what the group hopes to accomplish. The appropriate board, technical or community advisory board, would then approve the working group. The working group would be expected to give monthly updates to the appropriate board on the progress it's making. And while all communities and working groups are important, I'll just highlight a few of them that I'm actively on and new ones that are formed that are currently looking for members. So the first working group is the Package, Clinic, or Build Report working group. In the past, I monitored the build system and sent personalized emails to maintainers whose packages fail for an extended period of time. If a package remains in an error or timeout state, they are marked for deprecation and removed. This allows Bioconductor to maintain high standards of working and well-maintained packages. There are automatic emails sent by the build system, but it seems like most maintainers ignore them or they get blocked as spam. A personalized email works wonders, but it's time-consuming. So the core team in the past has helped with these notifications around release time when we really have to have all packages installing, building, and checking cleanly. We would really like to move this task to a working group that is dedicated to notifications and not required, but if motivated, help maintainers identify why their package is in an error state. I lead this working group, so if you're interested, you can contact myself directly. A newer working group is the Industry Working Group. This group aims at collaborating and engaging industry users of Bioconductor. It is important that we recognize the needs of Bioconductor in industry and what currently hinders users or where there are inadequate guidelines. The leads of this group are Nicole and David. If interested, please express interest on the industry Slack channel on the Bioconductor community Slack. A brand new identified working group at the last Community Advisory Board meeting is a social media working group. There was an expressed concern that Bioconductor has limited or no representation on particular social media outlets and platforms. We want to be as inclusive and reach as many Bioconductor potential users as we can, and not all platforms are widely used in different areas of the world. We want to explore what is popular in different regions, what works, what doesn't, and where Bioconductor could potentially have a greater participation and increased discussion. Please join the social media channel on Bioconductor Community Slack if you wish to be involved. A well-established working group that is always looking for help is the Multilingual Working Group. The Multilingual Working Group focuses on translating and hosting Bioconductor materials in multiple languages. We recognize that the majority of material is in English and that the material needs to be made available in other language for better reach and understanding. There are a number of people leading the efforts in different languages. If you're interested in participating, please reach out on the Community Advisory Board channel on the Bioconductor Community Slack. The next opportunity isn't really a working group, but we are always looking for more people to be involved with Bioconductor package reviews. We put out a call 2 years ago and we are still onboarding the applicants as we will reach out to everyone that applies. There are Bioconductor standards that reviewers need to learn and be comfortable identifying. Once onboarding and test reviews occur, a member will be added to the Bioconductor list of package reviewers to review incoming package submissions. The minimum requirement is being a maintainer of an existing Bioconductor package, as that indicates experience in code development and a familiarity of the Bioconductor review process. Interested members can apply on the contributions.bioconductor.org website, where there's additional material and expectations of reviewers. One last important upcoming change I wanted to highlight is the core team plans to update the default Git branch name for Devel. Bioconductor still uses the term master, which is not in accordance with diversity and inclusion, and we recognize has a legacy of negative connotation and can be offensive. The default Bioconductor Devel branch will be renamed from master to Devel. The release branch names will stay the same of release_x_y. So example for the current 3.16 release, the release branch is release_3_16. The switch has not occurred yet. We are making preparations and the core team will provide more details and announcements when we start initializing the change, but I just wanted to make everyone aware of the potential upcoming switch. As we close our presentation, I wanted to highlight some useful resources for asking questions and getting help. There are 4 main outlets for questions. The support site is great for general Bioconductor package usage questions. This should really be one of the first places to ask for help and assistance from the larger Bioconductor community. When a maintainer submits a package, they are required to sign up for the support site and get notifications when their packages are tagged in questions. So you have access to the maintainer's knowledge as well as other community members that may have encountered similar issues. There's also the BioC Devel at ourproject.org mailing list for questions regarding package development or for maintainers to ask questions if their package is failing on the build systems. Its purpose is really to link package developers to get help answering development questions on implementation and coding while following Bioconductor package standards and requirements. Next, GitHub. Many developers have packages in GitHub, and you can find many of the core team packages on the Bioconductor organization GitHub. We really would like to keep open issues for reporting bugs in code and feature requests. General questions concerning a package, running package code, or debugging an error that you receive should first be reported on the support site. Also, the Bioconductor Community Slack channel. It's open and anyone can join. For those of you not familiar with Slack, there are dedicated channels to discuss a topic in detail and ask more specific questions on topics. I also want to quickly highlight opportunities to get more involved with Bioconductor. Again, working groups are highly encouraged, and if you see a need for a new working group, please add it to the working group page via GitHub. If you're interested in joining a working group, please reach out to a working group lead for more information on getting involved and upcoming meeting dates. The Technical Advisory Board and Community Advisory Board will be having annual elections soon. The Technical Advisory Board advises on project and package level infrastructure, while the Community Advisory Board is really dedicated to developing, enhancing, and diversifying the bioconductor community. The Community Advisory Board nominations will begin in late December, early January. Technical Advisory Board nominations will be occurring later next spring. While currently there is a limited set number of elected positions, we encourage anyone that is interested in taking a larger bioconductor community responsibility to apply. The BioC 2023 conference save the date has been posted and announced. The conference is scheduled to run August 2nd through the 4th, 2023 in Boston, Massachusetts, and will have a virtual component for those that cannot attend in person. More details will be posted on Bioconductor channels as they become available. With that, I'll close similar to last year. I would like to thank the conference organizers for inviting the core team to speak. Thank you to my fellow core team members. I appreciate all the hard work and effort we all put into keeping the project moving forward. And a big thank you to all of you in the bioconductor community. Again, Bioconductor would not be successful without the contributions of all of you. Whether you're a first-time user or long-time contributor, we hope you found a welcoming and helpful community. Thank you.